Okay, so here's our last step in talking about chapter one. Correlational research is essentially what we settle for when we can't do an experiment. We might have representative samples, we might have all that in place, but it's a situation where it's not possible for one reason or another to manipulate the independent variable or to randomly put people into groups. And so the example I give here is you can't assign pregnant moms to use drugs to see if it harms their baby. It wouldn't be ethical, right? And so if our research question is what is the effect of crack cocaine on developing babies, we cannot do an experiment because that would mean getting a bunch of pregnant women, randomly assigning some to do crack cocaine and others not to, and you can see immediately why that is just never going to happen. Um, and so we have to rely on correlational research to do this. And so we use pre-existing groups, like women who are pregnant who use drugs, the pre-existing group, right? Or women who've given birth after having used drugs. And we compare them to women who haven't. But the fact that they come to us pre-sorted means we're not doing an experiment. We're doing correlational research. And so that's an important distinction. And so because of this, correlational research never, ever, 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 ever establishes causation. That is one of the most important things that you should remember from this course. And if we were in class, I would actually make you chant that back to me a number of times. So maybe you want to stop right now and chant that. Correlational research never establishes causation. It's a really important concept. It can, however, predict how variables will change in relation to each other. So as one goes up, the other variable is also going to increase, or as the first one decreases, the other one's going to decrease. And that's because we always have to assume that there might be variables that we're not in control of or not measuring, and we call these third variables. All right, so third variables, that's just the word. The other word you sometimes hear used is confounding variables, which just kind of means confusing variables. But essentially, these are variables that we're not measuring, that we're not controlling, and that are off in the wings someplace, actually affecting the outcome of what we see and making us believe that there's a relationship that doesn't actually exist. And so I'm actually going to ask you, there's an extra credit assignment. I would strongly suggest that you do, because you can get feedback from me about how well you understand third variables. But I would really suggest that you do that. And we'll come back in a couple of minutes and talk about third variables a little bit more again. But let's talk about the general things connected to correlation that hopefully you remember from the reading. There are two types of correlations, negative and positive, and this will be one of a couple of times when you and I use the words negative and positive, not to mean good and bad, or better and worse, but to simply tell you something about the direction of things, of what kind of relationship there is. And so think about the fact that two variables can either both change in the same direction. They can both get, kind of go up, or both go down, or they can change in opposite directions. As one increases, the other decreases. And that's what positive and negative refer to. Positive correlation is when both variables are moving in the same direction. So the example I give here is height and weight in children. As children get taller, their weight also goes up. And that's a positive correlation. So children who weigh more tend to be taller, children who weigh less tend to be less tall. And so if we plotted, right, if we took a graph and plotted we plotted every child's height and weight, we would see those go up, and that would be a positive correlation. A negative correlation is the opposite. A negative correlation is one thing goes up, the other thing goes down. As one variable increases, the other variable decreases. And so temperature and snowfall, right? And probably intuitively understand if we went through a year and we plotted on a graph the temperature and how much snow fell, we would find that the colder it is, the more likely it was snow was falling. So as the temperature dropped, snow likelihood increases. As temperatures go up, snow likelihood decreases, right? It's a negative correlation. And we can look at these visually, and I think that that's really helpful. So each of these dots, imagine that this is the height and weight. So a child who, if this is height and this is weight, a child whose height is here, their right, child one, their weight is here. Here's child two, their weight is here and their height is here, right? And so you can see if we graph it, that that's what a positive correlation looks like. And for those of you that remember math, and if you don't, it's fine. I'm never going to ask you for this back. But one good way of understanding this is to think about positive correlation essentially is positive slope. And that's why we call it a positive correlation, is that when we plot it, we can see that it has a positive slope. Negative correlation means that, right, if this is snowfall and this temperature, when the temperature is low, we have high snowfall, right? So this dot here would be low temperature and high snowfall. And the higher the temperature is, as we go up, the lower the snowfall is. And so we can draw a line through those dots, and that's a negative correlation, which you'll notice perhaps also has a negative slope. And then the last graph here, all the way to the right, shows no pattern. And so that's no correlation. It's a pattern where it's just kind of scattered, and there's no pattern that we can see, and that's no correlation. So, right, so that positive or negative, the direction of the correlation is one important thing to know about correlations, and then the other is how strong is the correlation. We're always going to express correlations with the letter R, which is a statistical term, and it stands for a Pearson correlation, and R is going to have a value between 0 and 1. 0 would be that no correlation that we just saw in the graphs, and then the closer we are to 1, the more of a relationship there is between the two variables. And if you looked at it in a graph, the steeper the slope of the graph would be. And so again, is related to slope. And, one would be that there's a perfect correlation, that every time one variable increased by 1, the other variable increased by 1. And we almost never see that. I would argue we never do see that in psychology. Nothing is perfectly predictable because we always have too many other variables that might be affecting things. So somewhere, right, so you get, this gets expressed as a decimal that, that somewhere between 0 and 1, the example here, right, 0.36 would be a less strong relationship than 0.82. And so if you understand decimals and how to figure, how to understand those, then you'll be able to understand correlation. And so if you put these two things together, what we get is an R value that equals some number with a positive or a negative in front of it. The positive or the negative is not a mathematical indicator. It just tells us the direction of the relationship. So positive 3.36 and negative 0.36 have the same exact strength. Just both variables change in the same direction, and then the negative one, they change in opposite directions. And that's the only thing that positive and negative tells you. So if we look at the idea of third variables again, one way of looking at this is very simple, is a positive correlation between ice cream sales and crime. We know this. As ice cream sales go up, crime goes up. And so you have to ask yourself, does it mean that people who commit crimes then go out and buy ice cream? Like if we wanted to come up with, if we thought these caused each other, or does it mean that if you eat ice cream, it makes you more likely to commit a crime? And I'm using this silly example because you're not likely to believe either one of those things is true, and you're likely to try to figure out what is it that's going on here. And you may have already figured out before even looking at this that there's a third variable, something we're not talking about or measuring, that actually is causing the changes that we're seeing in both of those things. And because it affects both of our variables of interest, it makes both of them change in predictable ways. And so in this case, it is weather, right? As temperature increases, ice cream sales increase. As temperature increases, crime increases. As temperature decreases, ice cream sales decrease. As temperature decreases, crime decreases. And so hot weather becomes this third or confounding variable, as we said before, that's off in the wings and dictating how things are going without us paying attention to it or measuring it. And so the extra credit that I've given you asks you to take some correlations that come from a class exercise I've done on ground, and asks you to first describe what you can say about the correlation, and I think there's an example in there that shows you how to do, but basically saying, in this case, it would be, that this positive correlation means that as ice cream sales increase, crime also increases. So let's say the correlation was R equals positive 0.36. You can say, well, that correlation tells me that as ice cream sales increase, crime also increases. And the important thing when you're talking about correlation is you cannot establish causation. So you cannot say that one of these is causing the other. You have to just give a description of what you're being told is happening and not why it's happening. But then your next step in a correlation is to wonder what other third variables might be there. And I'm going to ask you to focus on third variables as a way of keeping your attention on the fact that they exist, because that's a really important thing to remember. And so you're going to have that extra credit opportunity for the correlations. Again, you'll get extra points, but the real reason to do that is there's a high likelihood I'm going to ask you to do something like this on the test, and this gives you some practice doing that, and then the discussion gives you opportunity to construct an experiment with your group mates. And so you'll have practice for that as well. All right, thanks guys.